Alright, so for today's lesson, we're going to write radicals in rational and exponential form. We're just going to convert between the two, and then we're going to learn how to simplify. So first thing we want to review is some definitions. So here, letter A is our base, letter M is our exponent. So you're going to have a base. It's either going to be a number or a variable, which has a power on top of it, or an exponent. The exponent is the little number that's written up top. A lot of times we've just seen like x squared. So x would be your base, the 2 would be your exponent. We're going to look at radicals today. So we have, normally our root is a square root. Again, until today you've normally just seen 2's in here or nothing, in here. This number is going to change, that's your root. So normally we talk about taking the square root because it's a 2. We can take the cube root if it's a 3. We can actually put any number in there that we want. And then the number that's underneath the radical is called your radicand. That's the number that's got to be multiplied by itself to equal when you bring it up. So we're going to use our calculator. So I know some of these you probably know, but we're going to practice using our calculators. So my calculators have square roots above the x squared button. So on my calculator, to type the square root of 35 in, yeah, we know the square root of 36, square root of 36 is 6, but we're just practicing typing things in our calculator. So we would hit that second button or a shift, then the x squared because the square root's on top of it, type in our 36 equals, and we should get 6. If we move to question number 4, we need the 4th root. So to type this in our calculator, we're going to use the 4 first. So we're going to hit 4. So 4 first, then the second button. Then you're going to move up a key to what's called the caret key. Looks like this. And then whatever your radicand is. In this case, it's 256. So I guess this is here. So for this problem, you're hitting 4, which is your root, then second, caret key, 256. Somebody type that in their calculator and tell me what you get. 4. You can double check yourself. Is 4 times 4 times 4 times 4, 256. So you can check your answer by multiplying whatever number you get by the root, by itself, the number of times of the root. So 4 times 4 times 4 times 4 should give you 256. For question 3, we want the cube root of 125. So 3, second, caret key, 125, enter. What's it give you? 5. Because 5 times 5 times 5, oops, I wrote that on the wrong one, should give you 125. Try number 4, so the 5th root of 243. So 5, shift, caret key, 243 equals. Should give you 3. Mm-hmm. So at the bottom of this, we see the nth root rule. That's just how we convert between exponential and radical form. So exponentials on the left, we have an exponent on the left. And this is radical because it has a root. So here we're going to have a number, a variable, and then we're going to have an exponent. It's going to be a fraction. m divided by n. Remember, we can write whole numbers as fractions just as well. We can rewrite that as the nth root of a to the m power. Sometimes you'll see it with parentheses, sometimes you'll see it without parentheses. So sometimes it'll look like the top, sometimes it'll look like the bottom. So we're just moving pieces. So like the m moves up, the n moves down. I always try to remind my students that m is the numerator or the top of the fraction. It goes up to be the exponent. The n's the denominator. It goes down to become the root. Practice rewriting. So for question number 1, I'm going to write this in radical form. The first thing I know, the big number or the base stays underneath as normal size. Your exponent, those numbers are still going to stay small, but I've got to know which one goes where. One of them goes here, one of them goes up here. The top of your fraction goes up top. So the top of my fraction is a 3, whoops. So I'm going to move that 3 up here. The bottom of the fraction's a 4, so 4 becomes the root right in there. And that's how I would rewrite it. So sometimes you're asked to rewrite, sometimes you're asked to simplify. The first thing I would check, do I know the 4th root of 6? No, I don't know the 4th root of 6, so we're just going to leave it. Question number 2, again, we're writing in radical form. The 3x stays normal size, except it's written underneath your radical. This time, the 1 goes up top, the 5 goes to the bottom. So 1 is your exponent, 5 is your root. Question number 3, again, whatever's in your parentheses goes underneath your root. So even though it's x to the 3rd, that's okay. You're just writing it underneath just as it's written. Not right now. So all we're doing is asked to rewrite them, so we're just rewriting them. We're not going to worry about reducing until later on today.
But is it possible or not?
You can reduce it.
Yeah.
So 1 and 2.
Yeah.
See if you can do question number 4. So it's very similar to question 2. See if you can rewrite it and get the correct answer. So you should have the 7th root of 2x, and then your exponent should be a 2. So the 2 is in the numerator, so it gets moved to the top. We can practice the exact opposite. I can give you a rational form and ask you to write it in exponential form. So the opposite version, we're going to take whatever's underneath the radical and it automatically goes in parentheses. It is key that you put this in parentheses. The last slide, it didn't matter, but now the 3x must go in parentheses. So now I'm going to make my fractional exponent. The 5 is the original exponent, so it goes up top. The 3 is the root, so it goes on the bottom. So 3x has to go in parentheses to the 5/3 power. Question 2 in the middle is a favorite trick question. It's not really a trick question, it's just a tricky question. So the 2x has to go in parentheses. We know we need a fraction as our exponent. The numerator needs to be the exponent that's up here. What exponent's written up there? 1. Everything's to the power of 1 unless it's written otherwise. And then the most common root, we don't write it in there, so it's not a cube root because question 1, we wrote the 3 in there. What's the most common root? 2. A cube root, a square root, they don't write the 2 in there because it's the most common. So there's an understood 2 there. So this is actually 2x in parentheses to the 1/2 power. If I remember correctly, there's a question just like this on your next test. So there's not going to be an exponent written. There's not going to be a root written, and you've got to fill it in. Oh, thanks.
You're welcome. Very impressive.
Thanks. For question number 3, we have the square root of x to the 5th power. Again, the x goes in parentheses, and then I have to figure out my exponent. My original exponent goes up top, so that's a 5. What do I write in the denominator? So what number is written in here? A 2. So square root, they don't write the 2's in there. So x in parentheses to the 5/2 power. Questions on this before we start simplifying? So now we're going to evaluate 4 to the 3/2 in radical form, and then we're being asked to simplify. So currently I've given you exponential form. You have a base with an exponent. You're going to rewrite that in radical form. So my base goes underneath my root. The top number goes up. The 2, I can write it in there, but it's not necessary because it's a square root. But this time I'm going to ask you, do we know the square root of 4? Well, 4 is a perfect square. So we're going to take that highlighted part and we're going to simplify it or reduce it. The square root of 4 is 2. But have we done anything with the exponent of a 3? No, so we're going to bring it over. In your calculator or in your head, you can compute 2 to the 3rd power. 2 to the 3rd power is not 2 times 3. It's 2 times 2 times 2, which is 8. If you wanted to type that in your calculator, you would hit 2, caret key, 3 with no shift. So 2 to the power of 3 is what that really means. Let's try a few more at the bottom. So step 1, we want to rewrite 32 to the 6/5 as the 5th root of 32 to the 6th power. I promise on all of your test questions that ask you to do this, I'm going to give you 1 point for that initial step, showing me what you're doing first. So first step, rewrite it in radical form. Then I'm going to compute the 5th root of 32. We're not doing anything with the 6. We just need the 5th root of 32, which is 2. Because 2 times 2 times 2 times 2 times 2 is 32. Now we're going to figure out 2 to the 6th power is 64. Question number 2 at the bottom, we're going to figure out the cube root of negative 27 squared. So first thing I want to figure out the cube root, of negative 27. So in my calculator, I'm going to take 3, shift, caret key, negative 27. You're going to want to use the little plus or minus sign at the bottom, not the minus that's on the right side on your calculator. So the cube root of negative 27 gives us negative 3. We haven't done anything with the squared, so we're going to compute negative 3 squared. It's very, very, very important that negative 3 is still in parentheses because it's negative. Because we're needing to figure out negative 3 squared, which is negative 3 times negative 3, which is actually positive 9. If you type that in your calculator without the parentheses, your calculator will tell you -9 instead of +. I want you to try question number 3. Yep, you got it. So for your first step, you should have written the cube root of 64 squared. Then compute the cube root of 64 to get 4. So now 4 squared is 16. So 16 is your final answer. Questions on these? Anybody need help typing things in your calculator? You want to try one? This is the best one I've got. Let's try it with variables. So step 1 remains the same even when you have a variable. So we're still writing the cube root of x to the 6th to the 4th power. That is still step 1. So there's your first point. When you have variables, it's going to look a little different because I cannot type this in my calculator. I can't take x to the 6th and compute the cube root of it. What you're really having to do is figure out how many groups of 3 I can make with 6. So if we have 6 people and we put them into groups of 3, we're going to have 2 groups. So the cube root of x to the 6th is actually x squared. So you're just taking the exponent underneath, dividing it by the root. So 6 divided by 3 gave me that 2. I've yet to do anything with this 4. And now I'm kind of going in the opposite direction. Here I have x squared, so I've got 2, and I want 4 groups of them. If I have 4 groups of 2, I actually have 8. So you're going to multiply those together to get your final answer. So we divide the exponent to get it out from underneath the radical, and then we multiply it by the outer exponent. So x to the 8th is actually your final answer there. For the question in the middle, we're going to add in a number in front. So underneath, I'm going to have 49x squared. My root is 2, my exponent's 1. Neither one of those are actually necessary, so you could just write 49x squared. Do we know the square root of 49? Yeah. Square root of 49 is 7 because 7 times 7 is 49. What's the square root of x squared? X. So 2 divided by that 2 that's really not written in there gives us 1. You could write that 1 there, but again, any exponent of a 1 is not necessary. So you could just write 7x. See if you can at least do the first step on question number 6. First step is to rewrite it. Hopefully you wrote the cube root of 64x to the third all to the fifth power. So to simplify this, the first thing I need to figure out is the cube root of 64. So 3, second key, caret key, 64 equals 4. Because 4 times 4 times 4 times 4 is 64. If I have x to the third and I want to make as many groups of 3 as I can, unfortunately, I can only make one. I can make one group of 3 from 3. This is still to the fifth power. The tricky thing here is both terms are being raised to the fifth power, so I need to take 4 to the fifth power and x to the first to the fifth power. Well, 4 to the fifth power in your calculator, 4, caret key 5, gives you 1,024. And then I have x to the first to the fifth. When I multiply those together, it just gives me x to the fifth. So final answer, 1,024x to the fifth. It's not uncommon for you to end up with large answers or large numbers in your answers. If you look on the next page, you will see some problems to work on. Notice the instructions for the first 4 questions just ask you to rewrite it. It doesn't ask you to simplify, so all you're doing is rewriting it. You're going from exponential form to radical form. When you get to question 5, you're going from radical form to exponential. Again, not simplifying until you get to the back side to question number 9. So once you get to question number 9, then they turn into questions like these where you must simplify.